Hey everybody, it's CoolCoder here. Today we're looking at the longest consecutive sequence problem. So in this problem, we're given an input array of integers unsorted, and we want to return the length of the longest consecutive element sequence, right? So in the example here, we're given this array, and we can see that the longest consecutive sequence is 1, 2, 3, 4, which is a length of 4, so that's what we return. We also know that we have to solve it in linear time, basically, which means we can only loop through it once. So basically the idea here is one way to know if we should start counting, right? So how do we know that we should start counting this sequence? We know because we're at 1 is the lowest number of that sequence. And how do we know that 1 is the lowest number of that sequence? Well, because 0 doesn't exist in this input array, right? Because if 0 existed, then 1 would no longer be the beginning, and this would actually be longer. It'd be 5, right? So basically, our goal here is we want to look for the smallest number in a sequence and then start counting from there, right? So this is actually going to be starting at 1. So basically the idea here is as long as there's any elements, there's going to be a length of 1, right? So if there's any elements at all, the longest result is going to be 1. Even if there's no sequence, the length of a consecutive sequence is 1 because every number is in its own sequence, right? So we're going to start looping through this set, and we're going to check if the current number minus 1 exists in the set, right? To check if we're at the beginning of a sequence or not. So basically, we're looking to see if 99 exists. 99 does not exist, so we know we're at the beginning of a sequence. So then we can, in a while loop, we can check to see if 101 exists. And while n, which we can use that as the variable name, but the current number we can say is n, so n is 100. So as long as while n plus 1 exists in the set, we can increment these values and then check the get the max of the consecutive elements, right? So let's just walk through this. Current number is 100. We know we're at the beginning of the sequence because 100 minus 1 does not exist in the set, so we're at the beginning of the sequence. So now we're going to go into our while loop, and while number plus 1 exists, so 101, we are going to increment these values, right? So 101 does not exist, so we never get into our while loop, so we move on, right? So now we're at 4, and we're going to check to see if it's the beginning of a sequence, right? So again, we're going to subtract 1. So 4 minus 1 is 3, which does exist in the set, so we're not at the lowest number of a sequence, so we do nothing. We're not going to go into a while loop. So then we're at 200. Right, so 200 minus 1 does not exist, so we're at the lowest number in a sequence. So while 200 plus 1 exists, right, because we know we're at the lowest of the sequence, so then we're going to go to our while loop. While 200 plus 1 exists, we're going to get into our while loop and increment this value, right? But 201 doesn't exist, so we never get to our while loop. Now we move on, and now we're at 1, so the current number is 1. So first we're going to check if 1 minus 1 exists, which is 0, so 1 minus 1 is 0. Does 0 exist in the set? No, it does not, so we know we're at the beginning of the sequence. So we are at the beginning of the sequence, so now we're going to go to our while loop and say while 1 plus 1 exists. Sorry, that's not a 3, that's a 2. While 2 exists, while 1 plus 1 exists, go into our while loop, right? So 2 does exist, right? It's right there, so we increment this by 1. So this will now be 2, and then we're going to take the max value of result, which is 1, and consecutive element, which is 2, and that is going to be 2. So result will now be 2. And then we're going to update our current number, right? So we're not technically just moving to the next item in the loop. We're going to say while we're in the while loop, so we're going to increment the value we're at, right? So we are actually going to set the current number to 2. So now we're going to see if 2 plus 1 exists, which is 3. It does right here, right? 2 plus 1 is 3. 3 exists. So now we're going to increment consecutive elements to 3. We're going to add 1 to it, and then we're going to take the max result of result and consecutive elements, which the max value is 3. So this is now going to be 3. Right, and then remember at the end we're going to set the current number to this value, right? So we're now at 3, so this will be now be 3. So now we're still in our while loop. So while 3 plus 1 exists, we're still in the while loop. 4 exists in the set; it's right there. So we're going to add 1 to our consecutive elements. We're going to take the max value of consecutive elements and the result, which is going to be 4, and this is now going to be 4, and then we're again going to set the value here to 4. So now we're at 4 plus 1. We're still in the while loop. 4 plus 1 is 5. So does 5 exist? It does not. So we break out of the while loop. We don't increment these elements at all. Another thing to note is, so let's say there's the number 10 here. So we're going to, if the program were to continue, 3, we'd go to 3 and then see if 3 minus 1 exists. It does not exist, or I'm sorry, it does exist, so we're not at the smallest element. So we're actually going to set consecutive element back to 1. And if we realize that we're not at the beginning of a sequence, right? So 3, we're not at the beginning of a sequence, so we're going to set the consecutive element back to 1. And the reason we do that is because there could be a longer consecutive sequence on this side, right? So it could be 11, 12, 13, and 14, right? So that's a length of 5. So we don't want to keep the value of this other sequence, 1, 2, 3, 4. We want to set it back to 1 and then go from there. And so if this was true, if this was in the input array, this would end up being 5, and we know that 5 is larger than 4, so result would become 4. Result would become 5, right? But it's not. So the result in this example is 4. So this is a linear time solution and a linear memory solution. Linear time because we are only looping through the input array once, and linear memory because we are creating a set. So let's go ahead and code this up. Okay, so like I said, we're going to first convert the input array to a set, and we can do that by this. That will convert it to a set. We're going to keep track of the result and the current consecutive elements size. So, and we're going to set both of those to 1, right? So now we're going to loop through our set for n in my set. We're going to again check if n minus 1 is in the set, right? So if there's a smaller number in the sequence, we don't want to do we don't want to do anything, right? So if n minus 1 is not in my set, that means we're currently at the lowest number in the sequence. So then we want to start doing stuff. We want to say, okay, so while n plus 1 is in my set, now we're going to start incrementing our values, right? Because we don't want to increment unless there is another number in the sequence. So first we're going to say current consecutive elements, add 1 to that. we're going to add 1 to m as well, or n as the current number as well. And then we are also going to take the max of the two, the result and the current consecutive elements, right? And then, so if we know if there is a smaller number in the sequence, then we're going to set current consecutive elements back to 1, because we don't want this to be the same value for every single sequence, right? If there could be a longer sequence further in the input array, right? So if there is a smaller element, if there is a smaller number in the sequence, then we can just go ahead and set that back to 1, and that's it. That's all we're going to do, and then we're going to return result, and that should be it. Hopefully that works, unless I forgot something. Nope, that worked. And that's it. Thanks for watching. I hope you learned something, and I'll see you on the next one.